long division, the 8 is going to go on the outside. The 4, 9, 6 is going to go on the inside. You're going to ask yourself, how many times does 8 go into 4? It does not. You can put a 0 there if you want, but it's unnecessary to put a 0 at the front of a number. Then you got to do 8 into 48. That'll go 6 times. 6 times 8 is 48. So divide, multiply, then you're going to subtract that number. So that'll give you 1, and then you bring down. Okay? All right. Then 8 goes into 16 twice. We multiply. We get 16. We subtract. We get 0. There's nothing else to bring down, so you're done for this problem. And there is no remainder or anything for this problem. Okay? So that's some pretty basic long division. Number 2 is a little bit more difficult. We got, ooh, why did that happen? Let's see. Change that back to this. Okay. So we got 5 going into 2, 4, 7, 8. So you ask yourself, how many times does 5 go into 2? It does not. How many times does 5 go into 24? 4 times. 4 times 5 is 20. We subtract. We get 4. We bring down the 7. How many times does 5 go into 47? It'll go 9 times. 9 times 5 is 45. We subtract. I'm running out of room. We get 2. We bring down. How many times does 5 go into 28? 5 times. 5 times 5 is 25. I'm going to have to write this kind of like over here. This is not ideal. Ran out of room. We're going to get 3. Now, do we have, so we're getting like a remainder of 3, right? So there's a few different ways that you would do this. Sometimes when you were sometimes whenever you were in, like, what do you learn this in? 4th grade, I guess. You would do like a R3 to show there was a remainder of 3. So that could be acceptable if you were just doing a long division. You could, in this case, write your remainder as a fraction. It would be 3/5. So 495 and 3/5. But we don't really, this is something we're going to do actually with our polynomials, but the way that is best is to continue this and get a decimal for it. All right, so there is no number after the 8, but I could put a decimal point and put a 0, and then I could bring down that 0 right there to the 30. I know this is all out of order here. How many times does 5 go into 30? 6. 6 times 5 is 30. Now you do not have a remainder. Sometimes right here you'll get like repeating decimals. You keep getting the same thing over and over, like 3 and 3 and 3. But for this one we had a number there. So 495.6. Now, you don't have to be able to do long division with numbers because you are allowed to use your calculator and Desmos on everything. So you don't have to be able to do that, but we are doing long division with polynomials, and the process is the same. Okay, so let's look here. All right, so we're going to start off dividing a polynomial by a monomial. Okay, so poly means there's more than one. Monomial means that there's just one term, right? So everybody follow along closely here. We're going to have the number, this stuff right here goes on the inside, right? 27, oh, I'm not giving myself enough room. Hold on. Let's go back. Leave yourself a little space above your division so you can write things there. 27x to the 6th plus 3x to the 5th plus 9x to the 4th. And then, do I need to do that? Maybe. Well, if we need to add anything else, we could add like for example, if we get to that point, like where we need to add a decimal, like we could add a 0x to the third and a 0x squared if we need to. We might not need to, so I'm not going to do it yet. But we could add the zeros for the next terms. To do long division, you need these always to be in descending order. You need your highest exponent first, then the next lowest, then the lowest last. Our 9x squared would go right here. Okay, so here is what we are going to do. It's the same process as regular long division. We have to ask ourselves, how many times will 9x squared go into 27x to the fourth? So the numbers, how many times 9 go into 27? 3. Okay? Oh wait, I'm writing this in the wrong spot. But let's think about let's think about the x's, right? Another way of thinking about the division here, instead of thinking how many times does this go into this, I could think what number times 9x squared would give me 27x to the 6. Because what I want to happen is for that to go away. So definitely 3. How many x's? X to the fourth. Notice I wrote that above my x to the fourth right there. So I multiply 3x to the fourth times 9x squared gives me 27x to the 6. I subtract, which cancels, which is what we want, right? And then I bring down my 3x to the fifth. You can go ahead and bring down 9x to the fourth if you want, or just wait. Okay? Then I have to ask myself what times 9x squared is going to give me 3x to the third, x to the fifth. This is not the easiest. What number times 9 would give you 3? There's not a whole number. Almost 0.3. 0.3 works if it is repeating, right? 1/3, right? 1/3 of 9 is 3. So I would have, say I want a positive, so I have positive 1/3, and then I need x to the third power. So if I do 1/3 times 9, it gives me 3. If I do x to the third times x squared, it gives me x to the fifth. Okay, then I can subtract. You want that to cancel each time, and bring down 9x to the fourth. Okay. Now I'm asking myself, what times 9x squared gives me 9x to the fourth? Just the x squared, right? So x squared times 9x squared gives me 9x to the fourth. I subtract, I get 0. I don't have anything else to bring down, and I've got 0 here, so I'm done. I do not have a remainder for this. So my answer for this is 3x to the fourth plus 1/3 x to the third plus x squared. Now you guys know that we are in some kind of difficult territory right here, right? This is not necessarily easy stuff. So, you know, I'm going to give you more time. It's not ACT kind of speed you got to have for this. Wait, that's the wrong thing. I'm going to do that. This one. So, we are going to check it Desmos every time. The good news is that you can check this pretty easily, just like we were checking those other problems. If I do 27x to the 6, oh wait, hold on. I need to do a division key first. 27x to the 6th plus 3x to the 5th plus 9x to the 4th divided by 9x squared. It'll graph this. If I do my answer, 3x to the 4th plus 1/3 x to the third plus x squared. Just like with our factoring, if we've done it correctly, I should get the same graph, right? Which means if this is a multiple choice question, you could probably do it with just Desmos instead of, well, it's going to be hard if it's multiple choice, you'll have answer choices, so you can graph them and tell. If it's not multiple choice, you're going to have a much harder time. Okay? All right, questions so far? All right, let's try example 4. So same thing here. Oh, goodness gracious. I've got 8a squared is going to go on the outside. I'm going to have 4a cubed plus 24a squared plus a. And I'm going to say, what number times 8a squared would give me 4? You have to have something here. So normally we're looking for whole numbers. But no whole numbers will work, so we're going to use 1/2. How many a's need to go with it? 1. So I'm going to put this over here, 1/2 a. I'm writing it above the a because they have the same exponent, right? So 1/2 times 8 is 4. A times a squared is a to the 3rd. And this is what I want to happen. I want that to go away. I get 0. I bring down my 24a squared. So now I'm asking myself, what number times a squared would give me 24a squared? 3. All right, so just a 3, because I already got enough a's, right? 3 times 24a squared, 3 times 8a squared gives me 24a squared. Subtract, get 0. Bring down. Now, what number times 8a squared would give us a? Well, it would be 1/8, but the a is the problem, right? So, like, number-wise, we need a 1/8, but the a is a problem, okay? So, if you get to this point, what you have here is you really can't divide this anymore, and you have nothing else to bring down, right? Maybe if there was something else to bring down, we'd bring it down and see if we could put a 0 here and keep going. So, this is our remainder. Here is what we're going to do with our remainder, okay? We're going to put, if it's a positive remainder, we'll put a plus. If it's a negative remainder, we'd put a minus. Put your remainder divided by whatever it is you're dividing by. Now, in this particular case, a over 8a squared is a over 8. A squared is a times a. What can happen with the a that's on top and the bottom? They cancel out because they reduce the 1. Now you have to put a 1 right there, right? So this could be reduced. You could write your answer as 1/2 a plus 3 plus 1 over 8a. If you're doing, like, if it's one where you have to write it out, I don't mind if you leave it like this, that's fine. But most everything you're going to get is going to be multiple choice for these, so it's probably going to be written like this. So this would be our answer. We could type this into Desmos to see if that works. So if let's put Desmos over here, actually. Gracious goodness. Alright, so if I do use an X, not an A, because Desmos doesn't like that A. So if we graph that, and then we graph 1/2 X plus 3 plus 1 over 8X, we see those are the same graphs, so we've done it correctly. Okay, questions? Okay, so if something will divide evenly, you do not have a remainder, then that would be what we call a factor of the expression that's being divided. So if the remainder is 0, it goes in this blank down here. Come on. 0. The divisor, so what you're dividing by, is a factor of the expression being divided. So for this one, we could say that 9x squared is a factor of 27x to the 6th plus 3x to the 5th plus 9x to the 4th. Right? That is a factor. For number 4, did we get 0 as our remainder? We did not. We had to put this fraction over here on the end, right? So that one, 8a squared, is not a factor of 4a cubed plus 24a squared plus a. Some of the questions you get may not ask you to divide. They may say, is 9x squared a factor of 27x to the 6th plus 3x to the 5th plus 9x to the 4th? But you would be doing the same thing to see if you got the remainder. Actually, there's going to be a shortcut. We're going to learn for that too. Okay, questions? All right, let's try some more. And actually, let me go over here. I think I need some more room. This division takes a little bit. Let me give myself some more room here. Let's put that down there at the bottom. Or else you can't fix it on yours. Let's see. Okay, so I've got to divide x squared plus 3x plus 5 by x minus 2. This is going to be the same idea, but a little different because we've got a binomial that we're dividing by. So we're dividing by x minus 2. It goes on the outside. And then we've got x squared plus 3x plus 5. So what you want to do for this, it's a little bit like if you divide by, like if you're doing long division and you're trying to divide by 27. And you got 5, 8, 2, 3, right? You may just want to kind of look at the first numbers like you would do. How many times will 2 go into 5? You know, because 27, 58 might be a little harder to do. You kind of look at those first numbers. So we're not going to do that though. So what we're going to try to do is we're only worried about the first term right here, the x. So what times x would give us x squared? X, right? So above this one, because that's where I've just got x to the first power, x times x would give me x squared. But when I multiply, I'm multiplying the x times x, which gives me x squared, and I also have to multiply that x times that negative 2, which gives me negative 2x. So I have divided, I've multiplied. What do I do next? Subtract. So I've got to subtract this right here. Make sure you're subtracting both of these. What's going to happen whenever you're subtracting the negative 2x? It's really like you're adding right there. So the x squares will cancel. That's what you want to happen. That's why we picked x in the first place. 3 minus negative 2x is going to be positive 5x because that double negative becomes a plus. And then we got to bring down. It's just 5x because if you're adding, like if you're just adding two like terms, you have 2x plus 3x, it's just 5x. If you're multiplying, that's when you would end up with the x squared. So like right here, whenever we did x times x, we got the x squared right there. That's whenever the variables change. When you're just combining your like terms, adding or subtracting, you do not change the variable. Okay? All right, what number times x would give us 5x? 5. Positive 5, right? So we put a plus 5. 5 times x is 5x. Then we also have to do 5 times negative 2, which is negative 10. Okay, so I divided, I multiplied. What's next? Subtract. So I've got to subtract this. That means I'm going to do minus and minus here. But right here I've got a double negative, so really that's like I'm adding, right? My 5x's will cancel, but that's what I want to happen. I've got 5 plus 10, which is going to give me 15. What times x would give me 15? Nothing, right? Because it would have to have an x with it. So at this point, this is your remainder. So you would have 5x. I've ran out of room. Our answer is going to be x plus 5 plus we do our remainder on top. What do we put on the bottom? X minus 2, whatever you were dividing by. So this would be your answer. And I'm not going to take the time to do it, but we could go type both of those into Desmos. We should get the same graph. Question, is x minus 2 a factor of x squared plus 3x plus 5? No, because we got a remainder. Our remainder was not 0 there. Okay, let's look at example 6. Now, here's something you need to pay very close attention to. On example 6, I am missing a lot of terms in the middle, right? Because I am supposed to start with the highest exponent and then go down. Like this one, I had x squared, I had x to the first, I had the constant term that didn't have x's at all. For this one, I've got x to the third, and then I skip all the way down here to x to the negative 1. So when you're doing long division, here's how you need to deal with that. The x minus 1 will go out here. You need to put placeholder 0. So I've got x to the third. I don't have any x squareds. So I will put plus 0 x squared. I don't have any x's, so I will put plus 0x, and then I will put my minus 1 on the end. If you don't put those, if you don't hold the places for that, it gets really confusing on what to do. Okay, so if you're missing any terms, you want to plug in those placeholder zeros for that. It depends on which terms you're missing. So like if your highest exponent is x to the third, that means there should be an x squared and there should be an x to the first there. But since those two middle ones are missing, they get zeros. But you could have something like x to the fifth plus 4x cubed minus 3, right? If I were going to write that, I'd do x to the fifth plus 0x to the fourth, because that one's missing, plus 4x cubed plus 0x squared plus 0x minus 3. So if your highest exponent is 5, they need to go down 5, 4, 3, 2, 1, 0. And so whatever's missing gets a 0 with it. Okay. And so this one's x cubed, so we should have x cubed, x squared, x, and the constant term at the end. All right, so Elijah, what number times x would give us x to the third? Or maybe not a number. What times x would give us x to the third? Yes. X to the second. So I'm going to write it above this because it has x to the second. So x squared times x gives us x to the third. And then we also have to do x squared times that negative 1, which gives us minus 1x squared. Okay, I divided, I multiplied, now I need to subtract. Subtracting's sometimes kind of tricky because, you get that double negative right there. So really it's like you're adding. These should cancel every time. You're going to get 1x squared right here. You're going to bring down your plus 0x, although there are no x's, but we still bring it down. Okay, Carlos, what number times x, or what thing times x would give us x squared? Just an x, right? And it's going to be positive because we want a positive right there. So x times x is x squared, or 1x squared, and then x times negative 1 is a negative 1x. And then we need to subtract, so this becomes a minus. This is a double negative right here, so that becomes like you're adding. So this cancels. Here we get just a 1x. And we bring down minus 1. Okay. And so last term, what times x would give us x? Not an x. X times x would be x squared. A 1. 1 times anything is just itself, right? So we're going to put a plus 1 right here. 1 times x is x. 1 times negative 1 is negative 1. Right? And then I subtract, which really is like I'm adding that second part. And this cancels. This also cancels. We just get a 0 right there. So I don't have a remainder for this one. So I would just get x squared plus x plus 1. So this is a factor. This would be a yes. Okay. Again, we could check this with Desmos. We could just go there, type in x to the third minus 1 over x minus 1, and type in the second one and see if they match, and they should. Okay, everybody good here? Specific questions about what happened on one of these? Okay. All right, let's continue on. Okay. All right, here's where they get really tricky. This is something you are, well, this is somewhat tricky. 8's going to be really tricky. 7 and 8 sometimes are going to be presented in a way that you don't have to know how to do it. You can just type it into Desmos and see which one matches, right? There are, whenever we take a quiz on this, what I'll do is I'll probably put a couple, like if I've got 8 or, well, if I got 10 on the quiz, I'll probably put a couple that have to be done by actually factoring or dividing, and most of them will be ones that you could check with Desmos because they're going to have answer choices, right? So if 7 and 8 are like, oh, I will never be able to do this, that does not necessarily mean you can't answer a lot of these questions right, okay? So don't get too discouraged if it seems tough to you. It says, what is the result when 4x to the third minus 23x minus 14 is divided by x plus 2? If there is a remainder, express the result in the form q of x plus r of x over b of x. What is all that weird stuff at the end? What does it mean, r of x over b of x? What does it mean to do with our remainder? Like if our remainder is 7, what would we do? You'll write it at the end as a fraction. It's all it's asking you to do. So like rather than saying the remainder is 7, you would do like a r7, you would do 7 over x plus 2, if that were the remainder. So that's all that's asking you to do. Don't let that throw you off. That's how we've been doing the other problems anyway. So we got x plus 2. I've got 4x to the third. I should have 3, 2, 1, 0. Do I have an x squared? I don't have an x squared, so what have I got to put right here? 0x squared minus 23x minus 14. So if you're missing any values, you're going to put those in with a 0. Okay, you guys try this one. Okay, try this one on your own. I'm going to freeze my screen and do it up here. I want to see how you can do it. You can work with your neighbor if you're struggling a little on this. Alright, so you don't look at the second number, you look at the front. So what times x would give you 4x to the third? 4x squared. So that should be 4x right there. So what you're doing is you're multiplying this by x plus 2. So 4x squared times x gives you 4x cubed. 4x squared times 2 gives you 8x squared. So it's plus 8x squared. Okay.
So they're always, so you do the first number first.
Yeah, you're looking at that first number to decide what to put up here. But then once you get it, you have to multiply by both of these, so you should get 2 terms. Okay, right there. And then you'll subtract. Yeah. It has the x squared with it. It doesn't know what it is. Because it's just like, if you had 1 minus a, it'd be negative 7x squared. You keep it. Okay. And then you bring down that negative 23 to x. And so now you're asking yourself, what times x would give you negative 8x squared?
Which is
Negative 8x.
oh, negative x.
Yeah, because you want x here, you have to. So negative 8x. That goes up here. That's over your 5.
And then, so that will make this x, right?
Yeah. And then you also have to do your negative 8x times 2.
Which is going to give 16. And then you minus it again to make it positive.
Yep.
Negative 7. And then times 2 to get the 14 you put up there.
You got to bring down. Yeah, but yeah, the last part. Yes. Well, it should be negative 8 and negative 8 should be, so you're adding negative.
You got help.
Negative 8.
I knew what I was doing. Okay, yeah, yeah.
Subtract. Yeah. Negative 16.
How you square it out?
I know it's not right because you should not have
Never do that again. I don't know what emotion that just ripped out of me, but it was not going.
All right. Okay. I wrote it up here too, but let's look at Aiden's. Just so you believe somebody else. You didn't photomath this, did you, Aiden? You saw him? All right, let's see. Oh gosh, we always run out of time. Okay. All right. Okay. Let's look at Aiden's.
That Desmos, can we be using MathWay?
No. State's not going to let you use MathWay on your exam. Sorry. But they do let you use Desmos. Okay. So, this is correct here. Oh, wait. No, is it correct? You've made one mistake, Aiden. Let's see if you guys can see. Well, he didn't. He would have got it right if he used MathWay. All right, so 4x squared. Okay, here's what he's done wrong. 4x squared times x gives you 4x cubed. 4x squared times 2 gives you 8x squared. That looks beautiful. What do you have to do next? You have to subtract, right? So you are subtracting right here. Why won't it let me write? You are subtracting what you did, right, to get 0. You're also subtracting that, which means you should have a negative 8 right there. Because that's it. You always have to. That's the algorithm for long division. Divide, multiply, subtract. You have to subtract the whole thing. Subtract and then bring down. And so you should get negative 8x squared instead of positive 8x squared, right? So then you say what times x will give me, we should have a negative right here, right? So what you've done, your signs are just off on what you've done. So that should be a negative instead of a positive right there. So we got negative 8 times x gives us negative 8x squared. Negative 8x times 2 gives us, that should be a negative 16 right there, right? So we divide, we multiply. Now we got to subtract. So that becomes like a double negative, so it's really a plus. This one also becomes a double negative, so you're really adding it here. So you should be doing negative 23 plus 16, which is going to be negative 7. You actually, I think, did that part right whenever you did it, and because you got a positive 7 right there. That, or you made 2 errors that ended up in something better there. That negative right there, so instead of a positive 7, you would have a negative 7. Negative 7 times x is negative 7x, and then you'll have a minus 14, which matches what you had above. Both of these cancel out, and there's no remainder. So that should be a minus, and that one should be a minus. But otherwise, you were pretty close. Pretty close. Yeah. Yeah, you didn't use math layer. You got it right. Here is my work with it worked out without the crossing stuff out. Let's see. Where'd it go, though? Let's see. Okay. There's my work. Thank you, Aiden.
Wow, me.
Alright, so, for the sake of time, we are not going to do the next example, because it's even worse, and we need to get to doing these next problems. So, the next one is even worse because there is an x squared instead of an x. We're going to skip on that for right now. We're going to go to the remainder theorem, okay? Now, the remainder theorem, so if you've been like, oh, Miss Hyatt, this is terrible, I can't do this. Listen to the remainder theorem because it is a shortcut that makes this easier to answer lots of types of problems, okay? So, the remainder theorem states that if a polynomial is divided by any binomial, x minus c, which does not have to be a factor of the polynomial, the remainder is the same as if you evaluate the polynomial for c, meaning that you plug in c, okay? So, if the remainder is 0, then that would be a factor. We've already talked about that. Get a remainder of 0, you get a factor. Now, I know that's a lot of words. Let's look at it in practice, because in practice, it's really not that bad, okay? If 3x to the fourth minus 5x cubed plus 2x plus 5 is divided by x minus 5, what is the remainder? So, one of the ways to do this problem is to use long division and get your answer for your remainder, right? But I have already seen some blank papers and some, this is impossible, why are you asking me to do this looks as I look around. The remainder theorem makes it where we don't have to divide. Now, it only works if they're asking you for the remainder. So, there are times where this cannot be applied because it wants like the whole expression. But if they're asking you for the remainder, or if they're asking you if something is a factor, we can use remainder theorem. So what you're going to do is you're going to take your factor right here, and you are going to set it equal to 0 and solve. So that, you know, it should just be the opposite sign is all it is. 5 is all you're going to do. And then you're going to plug that number into this expression, okay? So 3 times 5 to the fourth minus 5 times 4 cubed plus 2 times, I don't know why I switched to a 4 right there halfway through the problem. Like, I've lost my mind. 5 to the third plus 2 times 5 plus 5. Definitely grab your calculator for that. You don't have to do that all by hand. So if we the calculator here. If I type that into my calculator, or Desmos, either one, 3 times 5 to the 4th minus 5 times 5 to the 3rd plus 2 times 5 plus 5. I get 1265. So remainder equals 1265. That would have been a terrible problem to do by hand too, because the numbers would keep getting bigger and bigger until you're dealing with stuff like 1265. So if you want to know the remainder and you have a factor that is just a x minus or x plus something, now it's not going to work. Like number 8, you could not use it for that one because you have an x squared, so it would be different. But for this gets you out of having to do the whole thing. Is x minus 5 a factor for this? It is not. What number should I get for the remainder if it is a factor? 0. Okay? So this would not be a factor if it had asked that. All right, so if I want to know if this function is divided by x plus 2, and I want to know the remainder, did I use the same? I used the same equation, didn't I? What number would I be working with here? -2. Because you're always taking this like it's set equal to 0, which means you would have the opposite sign. So you got to remember to do that. You got to use the opposite sign. So if I do 3 times -2 to the 4th minus 5 times -2 cubed plus 2 times -2 plus 5, we can type that into our calculator. To the 4th. 89. Let's make sure I get the same thing. Yep, 89. So for this, I would get 89 for my remainder. Much easier than doing long division, right? So if it's asking for a remainder, or if it's asking if something is a factor, we can just take the opposite sign and then plug that number in. Okay? Let's do this last one. It doesn't ask us for the remainder. It just asks us if this is a factor. But I know if something is a factor, that means the remainder is 0. So I just need to see if I get a remainder of 0 here. What number am I going to be plugging in?
3.
Positive 3, right? So I would just do, I'm not going to write it down, I'm just going to type it in the calculator. 2 times 3 to the 3rd plus 2 times 3 squared minus 16 times 3 minus 24. Carlos is so fast. He is correct. You get a remainder of 0, so this would be a yes. That is a factor. If you get any number besides 0, then you would say no to that. That's it. Oh, wait, no, what have I got over here? Okay. All right, now, here's what you're going to see on a lot of this. You can use long division for this, and you will get the correct answer. But what do you notice, like for A, what remainder did they get for A? 12. What about B? 88. 6 for C. Actually, it's -6 for C because you got that minus in front of it. It's a -6, and it's a -8 for D. So they all have different remainders. You could also type this into Desmos. But that's a lot to type into Desmos, right? You got to test all of those answer choices. It'll work. It's going to take you a while. But they all have different remainders. So what could be the quickest way to do this problem? We could plug in 2 into the numerator, right? Because we're doing this divided by x minus 2. So if I do, for this 2 to the 4th minus 3 times 2 cubed minus 10 times 2 squared plus 2 times 10. Let's type that in real quick. Anybody got it in already? Carlos, you let me down.
Now I took a break.
Lazy on me. Okay. I also got negative 28. I might have made a bad question. Did I type something wrong? I think I've made a bad question, guys. Oh, it's 20. I added 2. It's worse. Oh, I got times 10 for some reason. Alright. I should have used a 2 right here. Okay. Negative 8. Alright, so which one is my answer? D. Right? And I would still, if I was doing it this way, I'd probably still take the original and D and type them into Desmos and make sure I didn't mess something up. But what you're going to see, you got about 15 minutes to start your assignment here. That's the last one, isn't it? So what you're going to see on this assignment, I think there are only maybe 2 problems where you actually have to do long division to be able to get the answer. Most of these can either be done by graphing them in Desmos or using the remainder theorem. Okay? So I really need you guys to be able to either graph this stuff in Desmos or use the remainder theorem, because most of the problems we're going to see you're going to be able to do by that. I would love for you to also be able to do long division very well. But if you can't, you can probably still make a B on the quiz and test, right? So make sure you know how to do the Desmos and remainder theorem parts, and count it as a bonus if you can also do long division. Because as you could imagine, for me to get the whole class to be able to do long division well, I could spend weeks on this, right? Like for factoring, like I think if I was going to try to get everybody in this class to be able to factor and do long division well, consistently, we're talking like a month of work. Yes, we do not have a month. So, I think eventually probably everybody could do it. I also don't know that it would matter to you very much in your lifelong learning. So I think if you understand the principles and are able to do it with Desmos and remainder theorem, that will be good. Yes.
I wonder how you gonna succeed in life.
All right, got about 10 minutes. Everybody get started on this.